This video shows how to model difficult material quantities easily and accurately, specifically curtain wall framing, non-homogeneous material layers such as stud walls, and for materials with a non-linear cross-sectional profile such as corrugated sheet metal or double T floor slabs. The methods shown in this video have been designed to allow material quantities to be calculated accurately without having to model in more detail than you would during preliminary design. These methods are described in more detail on LCA Quick's Unit Converters sheet. Revit scheduling tools correctly measure the length of each individual curtain wall frame. The volume is calculated incorrectly unless you model the exact profile in detail greater than you would at preliminary design. The method shown in this video calculates accurate volumes from any profile without needing this extra detail. Volume is calculated by adding the cross-sectional dimensional property of the frame in units of cubic meters per meter length to the object's types parameter and then multiplying this by the schedule's measured length. I measured the cubic meter per meter value from a CAD frame detail to provide a default of 0.0013, but you could use your own value instead. The surface area of the frame can also be calculated using the same method, but with an area per meter value of 0.148 instead. This video shows how to calculate the building material quantities of timber, studs, and insulation without having to model each individual framing member. In Revit, only one material can be modeled in one layer at a time in the wall buildup. Modeling both materials requires modeling them as two separate homogeneous layers, despite it being a single non-homogeneous layer in reality. The solution is to scale the thickness of the two layers by a framing ratio calculated using the method outlined in New Zealand Standard 4214, so that the volume calculated in the Revit schedule is correct. This video shows how to calculate accurate building material quantities for materials with complex or non-uniform cross-sections, such as corrugated sheet metal or double T concrete floor slabs. The method is called the cubic meter per square meter method. For more detailed instructions, please refer to the unit converter sheet in LCA Quick.